And finally, I'm going to say a few words about how GloVe can be combined with other algorithms. So GloVe assigns vectors to words, right? So it defines a map from the vocabulary to the d-dimensional vector space over the real numbers. And usually, if you have documents, then we want to assign vector to the whole document. So for example, if we want to figure out which documents are similar to each other, so do some clustering, or if we want to label documents according to some classes. So this is done in a very simple way. So it is called a continuous bag of words. So we just take our document and compute word vectors for every word in that document, and then we just add them together. Now, notice that somehow in this, with this method, some meaning is going to be lost, right? So if, say, I don't know, if you look at, say, two sentences, one of them is SPMS is better than NBS, and the other one is NBS is better than SPMS, right? So the meaning is opposite, but the bag of words is going to be exactly the same. So this continuous bag of words is not really an ideal method, but very often it does a decent job. So, and after vectors are assigned to the entire documents, we can do some downstream natural language processing tasks. So here is an example of Donald Trump's Twitter. So I trained on, I think, a 100-dimensional GloVe on Trump's Twitter. So here are some, well, just a sample of words projected onto the first two components, right? So, but the full data is much bigger. So this is a sample of GloVe features for Trump's Twitter. They do not really mean anything. So so they're just numbers. But I can use these numbers to cluster, to split Trump's tweets into clusters using the k-means algorithm. So, and I've done that, and the table shows the number of tweets in each cluster. And supposedly, since GloVe has to do with semantic meaning of my words, so this should do quite a decent job of clustering together tweets that have similar meaning. Let us see. So what I'm going to do now, so for each of these clusters, so I just extracted tweets from that cluster, and I plotted the word cloud using words that only appear in those tweets, right? So these are word clouds by cluster. So let me see if it really, so this is the first cluster. So Trump, HTTP, so Donald, great. This is the second cluster. No, so stop. Third cluster. Second cluster. Third cluster. The real Donald Trump is still. Fourth cluster. Fifth cluster. Sixth cluster. Well, cluster 7 definitely looks very different. So now this HTTP, and so it means that and real Donald Trump do not appear here, but the words Democrats, president, country, they appear here a lot. So probably it really picked tweets that are different from cluster from the first clusters. And again, so this is another, this is cluster 8, and again it seems different. So this is cluster 9, and this is cluster 10, and cluster 10 is probably again a little bit different. In any case, so it seems to that these clusters based on GloVe, it is real. So it's not just random, but it does capture some meaning here. Now, but of course, in order to do a decent job out of it, so we need to play with hyperparameters of GloVe, and we should play with a number of clusters, and we should actually read tweets that that are labeled according to those clusters. But my point being is that it makes a lot of sense trying to do that. Okay, so another thing that we can do with GloVe is we can search for information, right? So imagine that if you have like a textbook on machine learning and you want to find a particular topic there, right? So you have a couple of or maybe you have not just a single textbook, but you have many textbooks on machine learning, and you want to find something about latent semantic analysis. So what you do is you make individual paragraphs of your textbook being these documents, and you try to find the paragraph that has the highest cosine similarity with your search. And it basically it is going to do a pretty decent job of helping you to search for information. Or you can just use these as features for regression and classification on text. So you convert texts to features using GloVe, and then you can feed these features into some other regression or classification algorithm like logistic regression or support vector machine or decision tree or anything. So there are more complex downstream tasks like translation or question answering, or sometimes people do text coherence analysis, so that they check whether every next sentence, whether it is really related to the previous one, or if it contradicts the previous one, or if it's just unrelated. So to do these tasks, pure GloVe is not really strong enough. So we need to combine word embeddings with deep learning techniques. And again, so just for your information, people used to do recurrent neural networks until about 2 years ago, and now transformers, which is a different architecture, they become the new standard. Okay, and that's the end of lecture 9. So please do the quiz and then watch a short summary after the quiz.